Hello, this is Mr. Huber. In this lesson, we're going to look at circles. The equation of the circle that you see here gives a general form for a standard circle with a center at the point h, comma, k. We've seen h and k used before, right? H, think horizontal, right? X-axis, horizontal this way. So x minus the x value of the center, right? That h is the x value of the center of the circle. This k value is the y value of the center of the circle. And then r squared is what the equation of the circle will always be equal to. R is the radius. Remember, it's always r squared. Okay, so we're going to see this equation here and how we can use it in different situations with circles. The first situation we see presented here says, what's the equation of a circle with center at 2, negative 5 and radius 3? So all we're going to do in here is taking the 2, negative 5, the h and the k, plugging them here for h and k, taking the radius 3, plugging it over here for the radius. So we could write this out relatively straightforwardly. It's going to be x minus 2 squared plus y minus negative 5 squared equals 3 squared. And then when we do some simplification here, we're going to have x minus 2 squared plus y plus 5 squared. Let's make that sure that looks like a y there. A little bit like an x. Y plus 5 squared equals 9. That would be the equation of that circle, with the center at 2, negative 5 and a radius of 3. Here, similar type question, again, just worded a little different. This is where we want to understand that equation of the circle we're working with and what the different parts mean, okay? So we have an equation for the translation of x squared plus y squared equals 25. This equation here would have a center at the origin. A center at the origin, right? It'd be like x minus 0 squared, right? So there's nothing being added to the x. It's not moving left or right at all. Nothing being added or subtracted to the y. It's not going up or down at all. The center's right at the origin, 0, 0. Okay? So now we're going to go to the left 3 units. So if it helps, you could think about what this means looking like on a graph. Okay? If we went left 3 and up 7, right? We'd have a center there at negative 3, 7. Now it's just like the problem we just had, right? Left 3. So that means if we're going to do x left 3 minus negative 3, it's x plus 3 squared plus y minus 7 squared equals 25. The radius doesn't change. If we take a circle and we move it up, down, left, right, shift it around a little bit, slide it around, it hasn't changed the radius. Okay? So be aware of what that means for a translation. Remember, a translation moving left or right, up and down. If it helps to draw what that center would be, right, going from the origin. So we start at the origin, we went left 3, up 7. Now we've got a new point for the center. And then we do just like we did here, where we had a point for the center. This one gave us a radius. Here we already had what the radius squared was as part of our equation. Before we see a couple more examples, let's talk about one of the greats in hockey, Mario Lemieux. On December 31st, 1988, he scored 5 different goals in 5 different ways. He scored an even strength goal, a power play goal, he scored shorthanded on the penalty kill, he scored on a penalty shot, and he scored on an empty net. 5 goals, 5 different ways. Pretty impressive. Mario Lemieux, if you're not familiar with him, he played 17 seasons with the Pittsburgh Penguins, and he was a Stanley Cup champion with them in 1991 and 1992, including winning the Conn Smythe for MVP in the playoffs both times, and he won the Hart Trophy for the regular season MVP another 3 times. His career was cut short and had some seasons missed in the middle of his career, actually, with lymphoma and spinal hernias, and he had a heart condition. So, he battled through quite a bit. Still managed to score 690 goals in his Hall of Fame career, and he had 3 games where he had 8 points in a game. So, one of the all-time greats, and a unique way to have a place in the record books by scoring 5 goals in those 5 different ways. All right, let's look at some more circles here. Not face-off circles, but circles in the coordinate plane. All right, what are the center and radius of the circle with the equation we have there? And then we want to graph the circle. Okay, so we want to look at the equation here, right? And this is going to tell us the h and k. That's important because we want to know where the center of the circle is if we're going to graph it. Okay, and it says what are the radius and center, right? So x minus 5, that means our h value is 5. So when we go to write out the center for this circle, okay, the center is going to be at 5 comma negative 3. Remember, this would be like y minus negative 3. Okay? So the k value is negative 3. So the center is at 5 comma negative 3. The radius equals, remember, this is the radius squared. So if that's the radius squared, the radius is the square root of that. So the radius is the square root of 16, which is 4. So we're going to have a center at 5 comma negative 3, right there, and the radius of 4. That means we want to go from this point, we want to go 4 units out to find the circle. So we're going to go 4 units in each of the different directions we can, and we'll get some points that are part of the circle. So if I go 4 units to the right there, I go 4 units up, I can go 4 units to the left, and I can go 4 units down. So the radius, right? The radius is the same, 4 here to here. It's 4 from this point to that point on the circle. Okay, 4 units from the center to any point on the circle. And then now I could draw in a circle, sketch it in kind of the best I can. It's okay if it's not a perfect circle. Just get an idea where some of those key points are and get an idea what the circle looks like with the center and a radius of 4. All right. Let's look at another opportunity to graph an equation. This one's a little different because we're going to have to complete the square. So this is a reminder on how we do some completing the square. So we want to rewrite this where the terms with the x's are next to each other. So we're going to have x squared plus 8x plus some number to complete that square. Okay. Then we're going to have plus y squared minus 10y plus some number to complete that square. And that's going to be equal to, and I'm going to have to go above the graph here, I'm running out of room a little bit, 8. And I'm going to add in, I'm going to write the plus blank and plus blank. Okay? Actually, we're going to write those in the different colors so we know where they're coming from. Okay? These are going to be those numbers we're adding in there after the 8x and the 10y. So we're going to have plus whatever we add there and whatever we add in blue. Okay? So we're going to add in something to complete this square. We're going to add in something to complete this square. We have an equation. That means if we add 2 to this side, we have to add 2 to this side. Do the same thing to both sides of the equation. So let's complete this first square. In order to complete the square, we take this b value, 8, we divide it by 2 and square it. So we're going to take 8 and divide it by 2 and square it. And that's what's going to go right there. So 4 squared, that's going to be 16. So we're going to have to add a 16 on both sides. Then we're going to take negative 10 over 2 and square that. Negative 10 over 2 is negative 5. When we square it, we're still going to get a positive. That'll be 25. So we're going to add 25 to that right side. Okay? And if you recall, the reason we do this is now what we have in red there, we can write as a perfect square. We can write that as a perfect square. That is x plus 4 squared. Okay? And then we're going to have plus, now what we have in blue, y minus 5 squared. Okay? And equals 8 plus 16 plus 25. So we add all that together and you get 49. Equals 49. So now we've got an equation that looks like the one we saw in the last problem. We want to graph this. Okay, so I'm going to draw in my x and y axes here. So I'm going to go, let's say here. Here I can tell from where my center is, it's going to be at negative 4 comma 5. It's going to be, most of this graph's going to be in the second quadrant. So I'm going to adjust that so I have enough room. Right, most of my graph's going to be over here. This is where the center is going to be. So I want to give myself some room over there. Right? And so my center, if we look back at our equation, right, the center is at negative 4 comma 5. Right? We get that from the h and the k values. Minus a negative 4, minus 5. And then now we can know what the radius is as well. It's going to be the square root of 49, which is 7. So this is, again, just like the last problem. We completed the square to get an equation in that standard form for a circle that we saw. X minus h squared plus y minus k squared equals r squared. And now we're going to graph this. So negative 4 comma 5. It's right here. Right? That's negative 4. That's up at 5. So we go to negative 4 comma 5, and that's our center. Now we need points that are on the circle. Okay, so we'll get some points on the circle by going 7 units from that center. So I'm going to go 7 to the right first. 1, 2, 3, 4, 5, 6, 7. Be right there. Okay. Then we go 7 units up. there. Okay, that would be at 12, right, if you wanted to count here, right, this is at 5, then we go up 6, 7, 8, 9, 10, 11, 12. We're going up 7. Here at -4, we go over 7, we'd be at +3. Now we're going to go to -11. 1, 2, 3, 4, 5, 6, 7. We're going to be right here on the edge of the graph. Almost ran ourselves out of room there, but not quite. And then we're going to go down 7 units and have a point right there. And now I could sketch in my circle, drawing it through those points around my center that I got. So I got my center and my radius, and I've got my equation graphed. Okay, so when you get your equation of the circle, x minus h squared plus y minus k squared equals r squared, and you can work with that in the different situations, different information you're given, and what you try to do with them.